Well, welcome everyone to another Carolina Snowflake meetup. And so this one is all about using Python and MindsDB for machine learning with Snowflake. And I think there's going to be a general focus here on MindsDB itself. So we can jump into some logic here. Now something just disappeared on my screen, so I'm just going to make sure I still have access here to everything. And Heather, you guys are still hearing me?
Yes.
All right, I have no idea what happened. Like the controls jumped from one side to another. Okay, no worries. All right, so we just kind of go over our standard meetup rules that we have. I think folks who have been here before understand we're trying to get everyone's participation, but if you don't want to participate, that's okay. Use the chat to throw in questions, and video is optional, but definitely try to be social. Check us out on all the awesome social platforms, Twitter, Instagram, Facebook, all that good stuff at Data Lakehouse. And real brief agenda for us today. We're going to talk about machine learning a little bit, how MindsDB intersects with that, and it attempts to democratize machine learning. A couple of use cases we'll walk through. We'll talk about the data set that we're going to use for this particular Zoom meeting for the meetup, and really kind of dive into some technical demo walkthrough with MindsDB, but also with Python on the way that potentially the same prediction can be made. And we're going to talk to you guys about that. And then, of course, we'll always highlight things about data and how we're getting data into Snowflake and things like that. So as I mentioned before, all the previous meetups are out there on YouTube, and we also post all of our code over on our GitHub for these meetups. So anybody who wants to try to recreate what we went over today, they can jump over there and clone that repository and do that. I'm going to zoom right through the Snowflake. What is it? What does it solve? Just again, Snowflake's an awesome cloud-based platform that really solves the problem of quickly ingesting data using cloud compute so that multiple types of data workers and data consumers can leverage and share data at scale. So let's talk about machine learning. All right, so a lot of us are familiar with SQL, and some of us, not all of us, are familiar with with machine learning at a high level. And so just a brief description of what machine learning is it's really an aspect of artificial intelligence, right? So there's several different levels. We'll just focus on machine learning, and it's really about providing a means for creating predictions and classifying data without having to program every single iteration or condition for how to use that data or how to classify or predict based on the data that you have for the particular outcome you might be seeking. And so really it uses historical data to do that. The more data a machine learning model or algorithm has, the better, more accurate that prediction can be. And so it's very important to know that as we're talking about MindsDB tonight, because they're all about trying to democratize machine learning. I mentioned before, some of us are familiar with using SQL. Hopefully you're here because of the Snowflake slant on the meetup. And so MindsDB provides this capability for leveraging some of your existing SQL skills in order to do machine learning, which typically you're using some other type of coding language to do that machine learning, such as Python, and there's some other ones I won't go into right now. And the machine learning can be really broken out into these three different aspects: of supervised, unsupervised, or reinforced learning. And again, we won't go into great detail. We've got some other material out there already on machine learning. Check out our other meetups. But tonight we want to focus on, again, MindsDB, which, as I mentioned, allows people who might not be able to write in Python or might not be able to write in some of these other coding languages to do machine learning, enabling them to use SQL, something they're already familiar with, and the language that's been out there for decades at this point, in order to do things like predictive analytics, create predictions through machine learning, and so forth and so on. And one of the ways it does that is by latching on to some of these existing leading databases that are out there. I won't read the list ad nauseum, but Obviously, Snowflake is one of those on the list, as we have highlighted there with a nice smiling face. And so that's what we're going to be talking about tonight, how we can leverage Snowflake and a data set from Snowflake to integrate with MindsDB and to allow us to produce a prediction using, in essence, SQL. All right. So again, we don't work for MindsDB, we don't work for Snowflake, but we do work with those teams. And at a high level, the problem that MindsDB is solving is this kind of really long process so far traditionally and historically of preparing machine learning models, doing the modeling, then of course, attaining all those different data sets, outside of potentially the database, maybe from a S3 bucket or Google Cloud Storage, getting all that prepared. And then, with that model, then trying to do that training, maybe doing a bunch of ETL to get the data in appropriately. And then a lot of times in machine learning, we use database data anyway. So again, we might use something from S3, bring that into Snowflake using, streams and tasks, what have you, leverage some other databases, integrate that, create some sort of, subset data set. And of course we have to keep history and, whatever we did the training on, so forth and so on. So what they're trying to do is really trying to solve this problem of having this huge machine learning ops. So just kind of like people look at DevOps for writing code, machine learning ops, and trying to get that into a place where it can be more democratized, I guess, in essence, giving more people access to the ability to create machine learning models and capabilities without having to, spread their skills so wide, right? Kind of bring it all into the database tier, or as much as possible into the database tier, I should say. So I've already kind of highlighted some use cases for machine learning and how we might apply MindsDB and the capability there. So we've talked about this on previous meetups, right? In case you're not too familiar with machine learning, again, really solves and adheres to these use cases of, forecasting and finance, right? Anomaly detection, right? Credit fraud, predicting sales, filtering applications and applicants from a human resources perspective. And there's a lot more, right? If you tie in manufacturing and logistics and some of these other use cases, they are plenty. And so one of the use cases we want to talk about tonight was around Shopify data and some of, orders, sales, products, so forth and so on. And Drew's going to get into more of that, but, just kind of highlight what we're doing. So we're basically taking Shopify data from a Shopify store. And so if you guys are familiar with Shopify, it's an e-commerce platform that really, you could think of it as democratizing, e-commerce merchants, providing them with a complete platform for, adding their products, creating a store or a shop, selling their products, everything behind an e-commerce store that you might want to put online. And so obviously that data is valuable from like a retail or e-commerce perspective. So we pull that data into Snowflake using a tool called datalakehouse.io. If you haven't been to datalakehouse.io, definitely check them out. And we're going to pull sales order data so we can forecast that using MindsDB. But we're also going to try to do a little bit of a comparative analysis, maybe at a very high level, comparing, hey, what are the capabilities of MindsDB, prediction algorithm versus, maybe a Python prediction algorithm using, linear regression and so forth. So we're gonna take a look at that as well. Just to kind of take a look at some data, and Drew, I think I'm still doing this piece here. So Shopify data, using Data Lakehouse to get that into Snowflake. So I'll just kind of click this button here and just kind of go over here and just kind of, view some data. So we typically use a database called Data Lakehouse Raw, kind of brings in the raw data. Here you can see we've got Shopify data coming in. So there's all these nice tables, these entities coming from a Shopify data source, or really it's the database that behind Shopify. So we can look at some of those data sets. So we're going to be looking at order header, order items, products, and checkouts. And so if we kind of take a look at our orders, just kind of scan that real quick. If I kind of do a preview on the data, we can kind of see we've got some variant columns here for address, customer ID, kind of a decent size table. We're getting at, order number, We can get over here to currency. Obviously, we're going to have things like other information about the particular sale, total, dollar amount, price, discount amount, so forth and so on. Look at line item, obviously in detail what's been purchased, right? The price, the quantity, the actual title of that item. And then we're going to look at some of the other data for checkout and so forth. So that's what we're going to use in our data set today. And so if I just jump back here to the slideshow, getting the data into Snowflake, pretty easy using datalakehouse.io. So, a decent amount of connectors there where we can pick Shopify, search for it, find it, enter the detail. And you can see here we use basically this target schema prefix of ecomco, and that's what you saw there, ecomco _ Shopify. All right. So that's data lakehouse getting data. And so in essence, we just did these steps, right? Use datalakehouse.io, connect to Shopify, then we create a connection to our target. So this is all on, all online, no code. Takes like 5 minutes to make this whole process work. Then we synchronize the data down to Snowflake. You can set an interval if you want, like, every 2 hours, every 6 hours, depending on how your data is changing. I think you can get as low as like whatever, 15 minutes or something like that, if your data is changing that fast. And then we deploy, into MindsDB. So we'll talk about that here in a minute. Right. And we took a quick look at the Shopify data already, kind of did that just kind of real time. And now we're going to jump into the actually using MindsDB to do some of the data prediction. So I'm going to hand this over to Drew real quick. Don't want to steal his thunder. Unless this is my part here, Drew. I'm looking at the slides. I think this is you. So I'm going to stop sharing real quick and then hand this back over to you, or hand this over to you to begin with.
Yeah, thanks, Christian. Thanks. It was a kind of a great overview of, what we're looking to do in really just kind of going through MindsDB and understanding how you can take specifically the, with Shopify data that we're looking at, and being able to create predictive insights based on a data set that you're getting from Shopify. So can everybody see my screen?
Yes.
Should be the MindsDB editor. So that's where we're going to start. And I guess one important note is I know Christian talked about getting data from Snowflake, and that's basically what we did for the most part, except we took one step right here where we exported that data from Snowflake into a CSV file in order for MindsDB to consume. We had a little bit of trouble when running through our, quick start and configurations with connecting to Snowflake. We weren't able to find some good documentation on that. But we were able to just use the CSV file editor or the upload file capabilities of MindsDB to get our data into MindsDB for that actual consumption process. So the process is as simple as uploading a file here and inputting the table name that you wanted to be referred to within MindsDB, and you upload it, and it's a very simple process. So ultimately, we're just going to display that process right here by running this show tables from files command, and we see that we have created a table in MindsDB called vendor order data, and that's the data set that we that came exactly from Shopify that Christian was showing you before, that was able to be extracted from Shopify via Data Lakehouse and put into Snowflake. So the only process that we changed up here is that we took it in a CSV file. So just a quick demo about that actual data set, and what we're showing here is very basic data set where we are looking at the number of orders by vendor on a specific date. So for Supply Dark, their vendor, they had 3 orders on February 9th. So pretty straightforward. And ultimately, what we want to do based on this input data set is to be able to predict orders we get in a specific day. So based on the vendor that we input. So if we wanted to see for Digimon or Barbie, however many orders that they have, or however many orders that they might be able to have on April 1st, this is what we're going to be able to use MindsDB to be able to do. So MindsDB is able to do the whole machine learning predictive analytics part of what Christian was discussing earlier. So right here, we're going to run a create predictor command, which is essentially just creating a training model. So we've got this data set in here that we've inputted via our file, and we're going to use this data to train a model. And we're going to call this model Shopify orders 5. And basically we're specifying to MindsDB, we want to create it from the files. I guess it's either a database or a schema, but we want to, and from that files database schema, we are trying to, we're specifying that we want all of that vendor order data just from our select star command here. And we're also telling the model that we are trying to predict orders, which is this field right here, using 2 parameters, using our order day and our vendor. So as our, we're trying to predict orders, our dependent variable based on our independent variables, order day and vendor. So we have done that. We've created our predictor. We'll just run that command real quick. And I've already run it, so it already exists. So if we are just, we can run a quick select star from the, this is a MindsDB internal table called predictors. We are just running it where our model name is Shopify orders 5, and it's saying that it's complete. So it's already trained the model. We found an interesting little piece here where accuracy is 0.0, and we have maybe an idea of that, why that's true, and because we maybe haven't run a bunch of test data on it yet. But we would love to do a little bit more investigation and to see why that is the case. But just it's a little bit more metadata, the rest of this, the rest of the fields in this little table here. So that's kind of what you get when you query from this MindsDB predictors table. And we can also run a describe command, which will give us an R squared score, as well as a little bit more metadata about the model itself. And again, we think probably the R squared value here is similar to that accuracy score that we were seeing in the previous table. But anyway, the beauty of MindsDB is, we've created this training model based on the data set that we input. But what MindsDB does really well is they have these the ability to create what are called AI tables, and AI tables are similar, they're similar to like regular SQL tables, such that they they include data, but they also infer based on inputs that you give it. So if you were to query the data that we had input from the file earlier, such that we are just looking for Barbie and the order date of 2022-4/18, well, that data doesn't exist yet because 4/18 is in the future. But the beauty of the MindsDB AI table is that we are is that based on the model that we trained, it will input both of these independent variables as such into the model, and it will output the actual results of the model. So this is where we actually run our predictions. The cool thing is that it's very similar to what you would expect when you ran actual SQL. So, for example, I'm just going to try and figure out what the predictive model would say how many orders would occur on 4/18/2022. So I run this, and it's specifying that I would probably have 5 orders on that day, and it does it according to a confidence level of 99.9%, which is also maybe something else we would try to investigate a little bit more. That seems pretty accurate, but obviously we would need to do a little bit more investigation as to why that number would occur like that. But yeah, so this is how you get your predictive analytics. This is, and it's almost by running just straight SQL. So just very, very cool features. And just if we ran one more prediction here for 6 days later, it predicts that we would have 2 orders. So you can replicate this SQL statement in order to get however many predictions. You could also switch up the vendor name, or you could switch up the order day. But I think the big picture is that here with MindsDB, you're able to run a predictive model based on a set of inputs from a file or a data set. They do have numerous data connections, as Christian was mentioning before. But when once you create that model based on those inputs from that connection, you are left with this very cool configuration in an AI table where you are able to run basically your own freedom of asking for predictions from the model. So very cool stuff all around from MindsDB is what we thought. But ultimately, when we were doing this, we wanted to see how it kind of would stack up against what you could do just within using machine learning with Python or with R or some other tool as you normally do. So what we ended up doing was we ran a linear regression model in a Python Jupyter notebook here. So ultimately, for the sake of simplicity, we went with linear regression. So we could have gone with something a little bit more complex, random forest, or any other machine learning algorithm. But we really just tried to keep it straightforward so as to keep kind of the focus on understanding how MindsDB works and being able to compare it against something concrete. So we went with linear regression, and ultimately it's a very similar process in terms of bringing in data, training data, and then testing it and predicting and creating predictions off of those, off of that trained model. So ultimately we start with bringing in that same CSV file that we referenced in the MindsDB walkthrough, that vendor order data CSV, and just a quick look at it. We've got, it's the same data set, so there's nothing too crazy. It's order day, the number of orders on that day for a specific vendor. And then ultimately our next step is creating a linear regression model using the linear model function here. And I think the big key with the data set that we are looking at and what we want to accomplish within linear regression is that the two that are kind of predictive fields are independent variables, what we were talking about earlier. Our order day and our vendor are categorical variables in this case. So categorical being they are discrete, they're not numeric, basically. So what we end up needing to do is we need to go through a process of converting these variables into numeric variables so that we can use that y equals mx plus b format of linear regression. So we do kind of go through this cleaning process here where we, first of all, just want to drop orders from our data set, and ultimately get down to a point where we are doing a little bit more massaging of the data to give us categorical or numeric variables. So we go through the process of turning order day into a numeric value. So I don't know. Anupam was the kind of curator of what we got in this code, but and I don't know about the off the top of my head the what value it's converting to right here, but I believe if it's anything like other values, if you convert from date time to numeric values, it's going to give you a value that is a certain amount of time from a given start point. So this 738,195 would be the specific amount of days from a specific start time, whether it's January 1st of 1900 or something like that. But so if you're looking right here between 738,195 and 738,215, the difference there is 20. So I think we're talking about a difference of 20 days, which would line up between February 9th and March 1st. So that's kind of what we've got in that numeric variable. And so we've basically converted our date to a numeric value. And what we need to do now is convert our vendor to a numeric value. But easier said than done when you're thinking about kind of the y equals mx plus b format. What we need to do is basically create a multivariate linear regression model in this case. So what our process is now making kind of almost a matrix looking data set where we are specifying via one-hot encoding the dependent variables that occur or independent variables that occur for a specific record. So if we're thinking about kind of going from this data set to this data set right here, we are saying that supply dark, for example, on our first record right here, isn't present in any of these variables, but except for the supply dark column. So this is just a way of representing that, yes, this record is specific to the specific vendor that we've got specified here. So via one hot encoding, we get this more matrix looking data set, but in essence, this is going to allow us to run a multivariate linear regression model, such that we're able to create, run predictive analytics on based on the order day and the actual vendor that we've got. So we run through kind of a process of actually fitting our linear regression model based on this new matrix via one hot encoding, and we have now created our model, which has if you're thinking about y equals mx plus b, but also in the format of a multivariate linear regression model, we've got a number of coefficients for each specific independent variable. So instead of looking at two variables, we're actually looking at 20, however many, 46 columns. So we're looking at 46 different independent variables here between order day and all of our vendors. And this is the coefficients that we're given for each of those independent variables. And a little bit more massaging here. But anyway, we want to end up getting to a point where we can run predictions based on our regression model. And this is kind of what we do here is we create a a bit of a test data set where we are feeding it a specific date, 2022 4/18, kind of like we mentioned in the MindsDB model. And we're saying that we want to specify the number of orders that we get for the specific vendor, Barbie, in this case. And when we do that and we run our test, we end up with 11. So it's actually predicting that on that date, we would have 11.36 orders for Barbie. So that's how we would go about running a linear regression and being able to predict based on kind of that vendor date or that order date and the specific vendor. So all in all, you can kind of see that it's a lot more extensive being able to run this code and getting everything all massaged to the point where we could do a linear regression on it, versus what we saw with MindsDB, where it was a matter of 8 lines of code, or however many SQL commands, 8 SQL commands that we ran. So ultimately, very simple is what the simplicity is what MindsDB gets at, and it really makes running predictive analytics quite a bit easier than what you would do in just a Jupyter notebook, just any sort of more manually created machine learning model. So Christian or Heather, do you mind sharing back?
Yep, got it over here. And yeah, I think there's a question. I was going to bring up one of the docs as well from these guys. So MindsDB is also open source for the most part. There's a Docker image that that can be used and leveraged for deploying it on your own local machine and playing with it. I think we had a couple of questions on. Let me see a couple of questions. If it's using an ARIMA model or LSTM, and I think at the end of the day, you can kind of bring your own models for the most part, right? Keras, really you can bring your own models, right? And I think at the end of the day, what MindsDB is trying to do is just democratize machine learning, getting more people who might have more SQL skills than Python skills, for example, more SQL skills than the machine learning skills, and bring those people and the organization into the mix, for working with the prediction capability that they might otherwise have to go to, let's say, more senior data scientists on the team, go through that learning curve and so forth and so on. So just jumping back over here, I think we hit this one. Let me get to the slideshow over here. All right. So we kind of covered those two aspects. Did you hit this one, Drew?
Yeah. So this is what I was kind of going to get into the next. Yeah. So kind of what we showed were 2 specific predictions for the MindsDB model and the linear regression model, where we ran a test point for April 18th, 2022, using the vendor Barbie. And what we found were was that MindsDB predicted that it would be 5 orders that day, whereas our linear regression model predicted 11.3. And what we ultimately, if you're thinking about linear regression and just the whole y equals mx plus b model, and the fact that our model as a whole, it was ultimately lending toward a graph that was linear heading up or heading northeast. We ultimately had a model that, if you think about it, for each day that passes, is going to we're going to have greater orders than we did in the previous day, so that it kind of exposes kind of the flaws of why you might not want to use linear regression in this case, and might want to do something more like some sort of time series analysis, like a REMA, as mentioned earlier. So, but again, linear regression was something we chose just for the sake of its simplicity and for the ability to you just get something off the ground and be able to show a direct comparison with MindsDB. So ultimately, no, that's not the model we would choose if we had a lot more time. But for the sake of demonstration today, I think it worked all right. So, but that is kind of the one comparison that we would keep in mind. But can you go to the next slide, Christian?
Yep. Sorry. There you go.
Yep. So I see, I guess, maybe a question in the chat about minimum sample size. And that's a great question as well. We used actually a very small data set in this case. It was, we might have been pushing on 3 figures for our training data set, which, again, for the sake of running larger scale machine learning models isn't going to do much good. But for the sake of demonstration, it was, I think it worked out all right. But so to answer the question, no, MindsDB doesn't actually need a minimum sample size for to be able to run, but for the sake of accuracy, it always helps to have a bigger sample size. So what we found was it was probably overfitting the model in a lot of cases based on that sample size, and that something you'd want to keep in mind as you build out any specific or any certain machine learning model. So, but yeah, and we kind of talked about maybe the next steps we would do with respect to that. The linear regression model is do a bit more in terms of getting it at that bigger sample size so that we could direct more resources or more of that sample size to be training and testing as opposed to just training data. And we definitely want to do something with respect to a moving average or an autoregressive model, something where we could take into account time series capability, because I think that's especially critical when you're using a date as an independent variable to be able to predict anything. So ultimately, this was for demonstration purposes, but the whole idea was with respect to what we did was kind of to just give a nice piece of background on what could be done in terms of inventory management. If you're able to predict the number of orders that you make in a specific day based on a specific vendor or based on any other certain given descriptive attributes, you're able to do a lot to know how much of what thing you would need to have in supply at a certain given time. And ultimately, that's going to help avoid major issues like a lot of what we've seen in the last 2 years, supply chain issues, anything like that. And granted, now MindsDB and our linear regression model aren't going to be able to take into account a global pandemic or anything like that, but just on a day-to-day basis, based on a period of historical data, you can do a pretty good job of making sure that you keep supply up and know when your biggest sales spikes are likely to occur. So ultimately, these two, and specifically MindsDB, is a great tool to be able to leverage machine learning with kind of a certain level of simplicity and being able to relate it to something that we all really have. I think everybody in this meetup probably has a pretty good idea of how to use SQL. And so to be able to almost do machine learning with SQL in mind, or with SQL as your tool, is a pretty cool capability. So you mind going to the next step, Christian, or next slide?
Sure, let me see here. I done that slide in there earlier. The slide, or let me see, I think that is.
I think that might have been it.
Yeah.
I don't know, Heather, were you going to do wrap up, or?
Yeah. She might be a mute.
Hey, sorry. Yeah, I can. If you want to, it doesn't matter to me.
Yep.
All right. So we're AICG. We're the creators of DataLakehouse.io, which is more than just an ELT tool. It requires no code. And as you saw, we were able to get that Shopify data into Snowflake relatively quickly. Right now, we have a no bad data program going on, a beta program going on, sorry. And you'll get some cool swag and access to datalakehouse.io, where we have a data catalog and a bunch of other cool features. And if you're interested in that, you can go to datalakehouse.io /beta. And I can put that in the chat for you guys if anybody's interested. Also, that's what your form will look like when you get on the site, and you just fill out that quick form and we'll send you some next steps to your inbox. And then on the next slide, I think we've got our no bad data mascot guy, which is just our little guy to show that we don't believe there's such thing as bad data, just bad processes. And if you can polish up your processes, you can do a lot with your data. So that is the end of the meetup, and we're just going to take some questions. If anybody has any additional questions, you can go ahead and ask those.
I had a question about DataLakehouse.io. I'm just curious as to what are the main use cases. I'm not sure if I totally understood what are the main use cases for when we might want to use that tool.
Yeah, so it's really a data synchronization tool. So if you're trying to do like change data capture, or you're just trying to get a data set ready for your business users, or any of your data pipeline or data flows, particularly in a Snowflake, it's a very powerful tool for doing that, setting it up on any type of frequency, really solving a lot of those use cases. And it tries to be more business value driven versus just trying to have 10,000 different types of connectors that really aren't paid attention to over time. Yeah. And then there's other features in there, like Heather mentioned. There's a data catalog for collaborating and adding descriptions on the data, attributes, columns, tables, what they mean, tagging them. It actually integrates with Snowflake object tagging feature. And then there's some other Snowflake administration features there, like creating new user, monitoring certain workloads and things like that. So hopefully that answered that question.
Yes, thank you.
Yeah. Yeah. So we've got a decent number of customers in there right now, from our private beta. And so we've been expanding our private beta into more of an open beta. And so looking for any companies that are, in particular on Snowflake, where they have workloads where they might be doing something through some other, potential use case or development tools, such as with like Airflow, or maybe they're using a different tool like SSIS or Oracle Data Integrator, where there might be some operational applications. And then, like Heather said, we've got some swag, and then just, we'll be able to distribute out for those beta companies. Any other questions, guys? Well, we'll be posting this code out to our GitHub repository. We'll send a note when that's done, and the video is posted on YouTube in case anybody wants to revisit it. But yeah, definitely recommend you guys check out both datalakehouse.io, but also MindsDB. We think they're early. I think the company's only like 3 years old. And so I think it's a very, very promising company. As a matter of fact, MindsDB is actually backed by the company, one of the companies that also backed MySQL and like MariaDB, if you guys are familiar with those databases. And so, yeah, we're looking forward to what they're going to really, really do with that platform here in the next few months to years. It's definitely one to watch. Well, thanks everyone. I think we can probably wrap up there, and we'll see you guys on the next one. I think one of our next meetups is also around Python and machine learning. Heather, is that correct? Or just Python with
to execute a Snowpipe. Yep, sorry.
Perfect. Yeah. Yeah. So we've got a few more meetups going. And again, if there's any topics you guys want to see, we've got an awesome team over here where we just, we do a lot of ML, we do a lot of Snowflake, we do a lot around data. So anything you guys are curious about, drop us a line over there on the Meetup channel or YouTube channel. And we'd love to put something together that really, really fits a request from the group. All right. Well, thanks everyone for hanging out with us tonight.